Welcome everyone. We are discussing simplification of inverse circular function into simplest form, then perform derivative. So, in part 1, we have already solved some simple problems of inverse circular function. Today, I will take some problem of competitive exam as well as board exam of WBJE and JEE main. So, problem number 1. Y equals to sin inverse sin x plus cos x. Sin inverse sin x plus cos x by sin x plus cos x by root 2. So our main aim will be, since it is sin inverse, to put argument in terms of sine using concept of trigonometry. Now this one is very simple. So sin inverse. So try to recall 1 by root 2 sin x plus 1 by root 2 cos x. So sin inverse, we want to express it in terms of sine. So sin A cos B. So 1 by root 2 you can write cos pi by 4. So cos x unchanged. This is sin pi by 4. So our main aim is to express it in terms of sine. So x plus pi by 4. So this is our main aim. Now the second one is sin inverse sin x equals to x if x belongs to principal value, that is minus pi by 2 to plus pi by 2. So what is your restriction? So minus pi by 4 less than x less than pi by 4. So our argument is x plus pi by 4. So add pi by 4 on both sides. So 0 less than x plus pi by 4 less than pi by 2. So this belongs to principal value, that is minus pi by 2 to plus pi by 2. So what is our main aim? If this argument belongs to principal value, then sin inverse sin x is x. So finally what you are getting? X plus pi by 4. So simplified form is y equals to x plus pi by 4. So what is dy dx? So this is simplification. Dy dx equals to 1. So look it again. This is sin inverse. So your main aim is to put it in terms of sine. Then if restriction is given, so you look whether the restriction belongs to principal value or not. If it is principal value, then it is x. And if no restriction is given, we suppose this argument belongs to principal value. Now second one also exactly same. So your main aim is to express it in terms of cos. So 1 by root 2 cos x, 1 by root 2 sin x. So cos x cos pi by 4 plus sin x sin pi by 4. You try to complete it. So this is exactly same that of earlier. Now problem number 5. Y equals to sin inverse 2 to the power x plus 1 into 3 to the power x by 1 plus 36 to the power x. So look, we have a formula 2 tan inverse x equals to sin inverse 2x by 1 plus x square equals to tan inverse 2x by 1 minus x square. So look, so try to express this sine inverse in terms of tan inverse. So look, sine inverse 1 to as it is 2 to the power x into 3 to the power x, and this is 1 plus 6 to the power 2x, 6 squared to the power x. So 6 to the power 2x. Now this is sine inverse 2 into 6 to the power x, 3 into 2, 6 to the power x, 1 plus 6 to the power x whole square. So this is formula of 2 tan inverse 6 to the power x. So this is simplified value. So look, if we use derivative of sine inverse x, argument is not simple. 1 by root under 1 minus x square, then ddx of argument. But look here, y equals to 2 tan inverse. What is y? 2 tan inverse 6 to the power x. So what is dy dx? 2 unchanged. Tan inverse x, 1 plus x square. Then ddx of 6 to the power x. So 2 into 1 plus 6 to the power 2x, 6 to the power x into log 6. Obviously, base is e. So here argument is only 6 to the power x. So if argument is not simple, you try to simplify it using formula of inverse circular function. Now, problem number 4. Y equals to tan inverse 2 to the power x plus 1 by, this is 1 minus 4 to the power x. 1 minus 4 to the power x. Now we have already discussed this one. 2 tan inverse x equals to tan inverse 2x by 1 minus x square. So 2 into 2 to the power x, 1 minus 4 to the power x means 2 to the power 2x, that is 2 to the power x whole square. So it is formula of 2 tan inverse power x. Now argument is 2 to the power x. So this is simple. So it is simplified form. Then you perform derivative. So your main aim is to express it in terms of simplest form. Now tan inverse 3a square x minus x cube, a cube minus 3a x square. So here argument is not simple. So try to use formula. So try to recall 3 tan inverse x, tan inverse 3x minus x cube by 1 minus 3x square. So x belongs to principal value. X belongs to principal value, that is minus pi by 2 to plus pi by 2. So here it is 1. So simplify it. So tan inverse, to make it 1, you have to divide it by a cube. So 1 minus 3, 1 is cancelled, x by a whole square. So 3 into x by a minus x by a whole cube. So look, x is replaced by x by a. Now So it is 3 tan inverse x by, so this is simplified form. Now what is derivative? Dy dx, 3 unchanged, 1 by 1 plus x square by s square into ddx of x by r, ddx of argument. So this to be noted, s square by s square plus x square into 1 by unchanged, derivative of x is 1. So finally 3a by s square plus x square. So simplify, then perform derivative. Now I consider 2 more problems. So these are problems of competitive exam as well as board also. So problem number 6. So tan inverse, suppose this is y, tan inverse. So 1 plus cos x. So this is 2 cos square x by 2. 2 sin square x by 2 within root. This is 2 cos square x by 2, 2 sin square x by 2. So I have already stated that root over is plus minus or more. So root over, you do not write this one as only cos x by 2, because if quadrant is mentioned, then we write it is cos x by 2 if it is first quadrant. So this is root 2, then sin x by 2, root 2 cos x by 2, root 2 sin x by 2 modulus. So do not take this is cos x by 2, you take mod, plus minus. Then see the restriction, 0 less than x less than pi by 2. So this implies x by 2 lies in 0 to pi by 4. So both cos x by 2 and sin x by 2 is positive. So then you can write tan inverse root 2 into cos x by 2, because it is in first quadrant, root 2 into sin x by 2, root 2 into cos x by 2 minus root 2 into sin x by 2. So root 2 is cancelled out. So you are getting tan inverse cos x by 2 plus sin x by 2 cos x by 2 minus sin x by 2. And we have already solved this type of problem in previous class. So this equal to, so look, dividing throughout by cos x by 2. So what we are getting, 1 plus tan x by 2, 1 minus tan x by 2. So this is tan inverse tan pi by 4 plus x by 2. Pi by 4 plus x by 2. So we are getting this. Now 0 less than x by 2 less than pi by 4. Argument is pi by 4 plus x by 2. So add pi by 4. So pi by 4 plus x by 2 less than pi. Pi by 4 plus pi by 4. So this argument belongs to principal value. So that is why it is pi by 4 plus x by 2. So this will be if argument belongs to principal value, then tan inverse tan x is x. So pi by 4 plus x by 2. So this is simplified form. Now what is dy dx? Pi by 4 is 0 and derivative of x is 1. Now finally, quote inverse 1 plus sin x plus root over 1 minus sin x. So look, 1 minus sin x, it is actually problem of some multiple angle. So we can write it cos square x by 2 plus sin square x by 2. And this is 2 sin x by 2 cos x by 2. So cos x by 2 minus sin x by 2 whole square. So root over 1 minus sin x equals to mod cos x by 2 minus sin x by 2. Now you look the restriction. So it is given that pi by 2 less than x less than pi. So pi by 4 less than x by 2 less than pi by 2. So x by 2 lies between pi by 4 to pi by 2. X by 2 lies between pi by 4 to pi by 2. So in pi by 4 to pi by 2, in 0 to pi by 4, in 0 to pi by 4, look at the graph. If it is pi by 2, this one is pi by 4 intersection. I have already discussed it in pi by 4 to pi by. So sine curve, this one is sine curve and this one is cos curve. Sine curve is above cos curve. So sin x by 2 is greater than cos x by 2. So in this restriction, root over 1 minus sin x equals to sin x by 2 minus cos x by 2. These to be noted because sin x by 2 greater than cos x by 2. So root over 1 minus sin x equals to this. Now similarly, root over 1 plus sin x equals to modulus of cos x by 2 plus sin x by 2. Now x by 2 lies in first order. This one is positive, this one is positive. So this is cos x by 2 plus sin x by 2. But root over 1 minus sin x is this one. So this should be noted. So this is most important problem for competition. Now try to simplify. So this is y. So put in parts. Put the value cos x by 2 plus sin x by 2. I have already discussed. This is sin x by 2 minus cos x by 2. And this is cos x by 2 plus sin x by 2. And this is sin x by 2 minus cos x by 2. So this one is plus. This one is plus. Now this one is 14 parts. 2 sin x by 2 and this is 2 cos x by 2. So 14 parts 10 x by 2. So 14 parts 10 pi by 2 minus x by 2. Now look at the restriction. So it is given that pi by 2 less than x less than pi. So pi by 4 less than x by 2 less than pi by 3. So multiply it by minus. So minus pi by 4 greater than minus x by 2 greater than minus pi by 2. So add pi by 2. So if we add pi by 2, so pi by 2 minus pi by 4, this is pi by 2 greater than pi by 2 minus pi by 4. So this is pi by 4 greater than pi by 2 minus pi by minus x by 2 greater than 0. That is this argument 0 if we write in reverse form. So it belongs to principal value. So cot inverse. So this is tan x by 2 cot x by 2. Now this belongs to principal value. So final result is pi by 2 minus x by 2. So look it again. This is typical one for restriction. 1 plus sin x. So cos x by 2 plus sin x by 2. But 1 minus sin x is mod cos x by 2 minus sin x by 2. In the interval of pi by 4 to pi by 2, sin x by 2 is greater than cos x by 2. So that is why this one. But if it is given in this restriction in first quarter, then root over 1 minus sin x equals to cos x by 2 minus sin x by 2. Because in this case x by 2 lies between 0 to pi by 4. So using this concept, this is cot inverse tan x. So cot pi by 2 minus x by 2. Now you verify whether this argument belongs to principal value within the said restriction. So it is within principal value. So what is the simplified form? Pi by 2 minus x by 2. So if you perform derivative, so this is minus. This is minus half. So today through this video I have solved some important problems of inverse circular function. So first, using property of trigonometry, problems are reduced to simplified form and then perform derivative. So thank you for today.